this is part 2 of our comparing functions notes. It's the back of uh, the notes examples. And today what we have is we have the function 1 over x, and we have the function 1 over x squared. And if we draw those parent functions in quickly, there's 1 over x and 1 over x squared. And I just have a brief sketch of them, as you can see, because I only have 1 or 2 key points on there. But if we take a look at our first function here, f of 0 compared to g of 0, what we have on both of these functions is we have an asymptote. Our graph never touches x equals 0 in either function, and because the graph doesn't touch for either of them, we can say that this does not exist. We can't compare. D and E does not exist. And if we do 1 divided by 0, we have undefined. If we have 1 divided by 0 squared, we still have undefined. But for the next part, if we have f of 1, well, 1 divided by 1 is 1. And 1 divided by 1 squared is still 1. When we compare these two functions, these are equal. F of 2, well, 1 divided by 2. Or 1 divided by 2 squared. 2 squared is 2 times 2, which is 4. And 1/4 is smaller than 1/2. So what happens here if we negate those functions? If we have negative 2, f of negative 2, well, f of negative 2 is going to be 1 divided by negative 2. And g of negative 2 is going to be 1 over negative 2 squared, and negative 2 times negative 2 is positive 4. And we have a negative value for f of negative 2, and we have a positive value for g of negative 2, which means that f of negative 2 is going to be smaller than g of negative 2. If we do 1 over 100, when we put 100 back into our f function, we get 0.01. And if we do 1 over 100 squared, we get 0.0001. And which one of them is smaller? Well, when you compare, remember that the first zeros are the same, so then in our second decimal space we have a 1 here, and then we have a 0 for g of 100, and 1 is bigger than 0, so g of 100 is smaller. And then finally, when we do negative 100, remember this is just going to be negative 0.01. But when we square, even if we don't know what that value is, negative 100 squared, negative times negative is positive. So over here we have a negative value for f of negative 100, but we have a positive value for g of negative 100, which once again means that our f function is smaller than our g function. And if you kind of look at the progression here, we can't compare with the zeros, but 1, they're equal, and then 2, our g function is bigger, and when we get to 100, our g function is still bigger, which means when we compare here, that when we're comparing f of x to g of x, what happens is that f of x will be greater than g of x. If we go the other direction, and we can look at this on our calculators as well, but as x approaches negative infinity. So -2 is our first spot where we get the fact that f of -2 is smaller than g of -2. And then we go over here to f of -100. It's still less than g of -100, and -100 is getting smaller and smaller. We're getting closer and closer to negative infinity, which means when we have x approaches negative infinity, we've got f of x is going to be less than g of x, because when we square a negative number, it always becomes positive. So here's our last two functions. F of x equals x squared. So we can graph that function. And then our g of x equals the natural log of x. And it's 8, a little bit more than 2. There's our picture. And what we want to do is we want to compare these two functions. And when we start off with our f of 0, so we're comparing f of 0 to g of 0. And when we look at our first function, we can put 0 into x squared and get 0 out. But if you look at the picture here of our green graph, 0 is not part of the domain. 0 is not part of the domain, so we don't have any basis for comparison. So this is the does not exist, DNE. We can't compare. But we can compare on the next one there, f of 1. So when we compare f of 1, 1 squared is 1. And the natural log of 1, if we don't know what it is, we can look at the picture. So x is 1, what's the corresponding y value to that? It's 0. And which one is smaller? Our 0 is smaller than f of 1. And if you don't like looking at the picture here, f of 2 isn't too bad. 2 squared, 2 times 2 is 4. We can go back into our calculator and type in the natural log. And maybe we can. The natural log of 2. And I still have it up here from earlier. The natural log of 2 is 0.69, but let me show you just how to type it in. Your natural log button is here, the third button up from the bottom left. And then we could put in the 2. And when we press enter, we get 0.693. So 0.693 here, and what we can see again is that g of 2 is smaller than f of 2. So I wonder what happens when we deal with the negative here. And f of -2, -2 squared means -2 times -2, which is positive 4. But when we come over here, once again, I don't even need to type it in the calculator, because this is g of x, g of -2, g of x. And as we look at our picture here, do we have any x values in our picture that have a -2 in them? And it doesn't. And if you don't see that on the graph, then if you type in natural log of -2, you can probably guess what we're going to get, which is an error. So again, on part D, we don't have any basis for comparison. But we do for E. We've got f of 100, and if we square 100, we get 10,000. And then let's look at what our natural log of 100 is. So natural log of 100 gives us 4.6. And it seems that our pattern, when we can work with these, is that G is smaller than F, which is going to help here. And in fact, even before we look at this last one, if we look, when we started with 1, G of 1 was smaller than F of 1. And then we increased it to 2, and G of 2 is smaller than F of 2. And then when we got to a little bit bigger numbers, G of 100 is still smaller than F of 100. It looks like here, without even looking at it on the graphing calculator, that as x goes to infinity, as x gets bigger and bigger and bigger and bigger, what happens is that our function, f of x, is always greater than g of x. Now, for f of 0, we couldn't compute that based on our natural log graph. And when our x value was a negative, we couldn't compute it over there when we have g of -2. We can figure out what f of -100 equals. But if we go and try to figure out what g of -100 equals, you probably can guess that, again, it's an error, and we cannot compute this. And consequently, when we're looking at this, it says which is greater as x goes to -infinity. Well, one of the graphs doesn't go towards -infinity, so we have no basis for comparing on this one. So the only one that we can compare is that as x goes to infinity, f of x is greater than g of x. We can't compare here.